Everybody. So we're going to talk about theorems and proofs, which before we talk about that, we need to talk about axioms and conjectures. So an axiom is also known as a postulate. They mean the same thing. It is a statement that is assumed to be true, usually like a very obvious statement, and therefore needs no proof, right? So here are some examples of axioms. The sun rises from the east. Humans have one brain, lizards give eggs. These things are assumed to be true. We don't need to cut a bunch of people open to figure out that we have one brain, right? In math, here are some examples. Two parallel lines never intersect, right? We don't need to prove this because we just assume that it's true. And you can read these other ones. We'll talk about number 5. Things which are equal to the same thing are also equal to one another, right? So imagine that I have 2 blocks of, I don't know, ice, right? And I weigh these things and I figure out that they have the same weight, right? And my friend also had this block of the same block of ice B, and he weighed it and he figured out that it was the same as his block of ice, right? So A is equal to B and C is equal to B. Then we know that A is also equal to C, and so that's what that is saying, and that's, you know, an obvious thing that we don't need to prove, but we just assume that it's going to be true, right? So that's what an axiom or postulate is, right? A conjecture now is derived from deductive reasoning. So what this means is it's an educated guess, right, based on observed patterns, right? And so one pattern you may have noticed as you've done some math is when you square a number. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. You might make a conjecture that says the square of a number is always greater than or equal to the number itself, right? So for example, 1 is greater than or equal to 1. 4 is greater than or equal to 2, right? The square of 2 is bigger than or equal to 2. 9 is greater than or equal to 3. 16 is greater than or equal to 4, right? And you notice this pattern. And you're like, oh, I'm going to make a conjecture, right? You have not proven anything. It turns out that this conjecture is actually false, right? Conjectures are not always true, because later when you get to higher levels of math, we've probably already done it. If you square 1/2, you get 1/4, and 1/4 is the squared number, is not greater than or equal to 1/2. And so this conjecture is false, right? So what do we have to do to make something more advanced than just a conjecture? Well, we need to do a proof, right? So in math, a proof is a logical sequence of arguments whose goal is to convince people that something is true. But this is unlike in a court of law where you could have reasonable doubt. Every step of the proof must be proved to be true in every case without any doubt. Let's take a quick example, right? Let's look at something called vertical angles, right? So if I just draw 2 lines, right, any 2 intersecting lines, 4 angles are created, right? Angle 1, 2, 3, and 4. And you may notice that, hey, angle 1 and 2 look like they're equal, and angle 2 and 4 look like they're equal. They look like they're always, and you know, you maybe realize that no matter how I draw these lines, that's always the case. So you might want to, you know, try to prove this. In fact, these are called vertical angles, right? 1 and 3 are vertical angles. One way to do a proof is to do like a statement and a reason, right? So one thing we might say is that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees, right? Basically, if I add this angle to this angle, I get a straight line, and in a straight line, there's 180 degrees. And you might say that same thing about if I do measure of angle 1 plus the measure of angle 2, that should also be 180, right? So that's going from here to there. Oh, that's too much. That's going from here to here, which is also a straight line, right? And what's the reason of this? Well, you could just say, okay, straight lines have 180 degrees, right? That's like a postulate in itself. Like we came up with that convention, right? And then what we could do is we could basically do a substitution in here. Like since they're both equal to 180, I could go ahead and write that, right? I'm just substituting 180, since 180 and these two things are equal, I'm substituting them. And then I can subtract measure of angle 2. So the reason with this would just be algebraic substitution. I subtract measure of angle 2 on both sides, right? And they're going to cancel, and I'm left with measure of angle 3 is equal to measure of angle 1, right? And this is just from simplifying. So now I have proven that measure of angle 1 and measure of angle 3 are congruent, and this is now a theorem, right? So there's a theorem out there that says vertical angles are congruent. And now that you know that, and now that you've proven it, you never have to prove that again, right? You can just go with that theorem and always work with it. And so that's what a theorem is, right? A theorem is a statement that has been proved or proven, often with the help of an established axiom. So here's the theorem we just did. Vertical angles are congruent, meaning they have the same measure, right? And we just proved that one together. Another example would be what you've been looking on Khan Academy is here's a postulate that if two parallel lines, right? So here's a parallel line, two parallel lines. If they're cut by a transversal, here's the transversal, then corresponding angles are congruent. So that would be this angle and this angle, right? And that's a corresponding angle postulate, and we could actually that's assumed to be true, right? And we could create some theorems based on that. So the point of this was for you to understand the difference between an axiom, conjecture, proof, and theorem, right? So review this again just to make sure you understand what the differences are.